Hi gang, let's review finding the domain of a square root function. You're going to be asked to do that on the exam. So let's just review that concept. So if you have a radical with an even index, you can't have negatives under the radical. If you have a negative under the radical in the real system, that has no solution. So just to be clear, in the real system, like if you have a negative under the radical, hold on a second, the light doesn't seem right. Yeah, okay, so in the real system, a negative under the radical has no solution. Sometimes people get confused because they're assuming they're in the complex system. So in the complex system, the square root of -4 is 2i. Okay, so but we're going to be in the real system, so that's no solution. The real system is a subset of the complex system. So what we have to do is we have to take what's ever under the radical, which is referred to as the radicand, and we have to make sure that that is greater than or equal to 0. And they're asking for it in the in interval notation. So just as a reminder, so when I draw this on the number line, this starts at 0. It's allowed to include 0, so it gets a bracket. Bracket means include, parenthesis means exclude the boundary. Bracket means include the boundary, parentheses mean exclude the boundary. So graphically it looks like this in interval notation, the interval notation on the graph. And then the domain would look like this because it includes 0, so you want to have a square bracket, not a parenthesis. If you have a parenthesis, it means you're not including 0, which would be in the other system like an open circle, not a colored in circle. All right, let's try another one. So again, if you have an even index on a radical, that means what's underneath in the radicand must be greater than or equal to 0, and then you have to do the algebra on it. So here I would have to subtract the 4. So if I graph this now, this would mean that x has to be greater than or equal to -4. And again, I'm going to use a square bracket because it includes -4. So the domain of this would be -4 to infinity. Okay, so this one here won't be the exact one on your test, but it will be something generated like this. So this one's a little trickier because you have the negative in front of the x, so let's work this one out. So it just depends how you want to move this around. You could technically move the x over, but I'll sort of do it the longer way just to make sure we're on the same page. So I move the -2 over. Now remember, whenever you multiply or divide by a negative, you have to flip the sign. So here I'm going to divide by a negative, which means that I have to flip the sign. So again, whenever you multiply or divide by negative, make sure you flip the sign. It's going to flip the domain over the y-axis, right? You're now going to the left instead of the right. Okay, so what that guy's... Oh, let me stay in 1D here. Okay. Okay, so then what that looks like is we're going to be at 2, but we're going to be less than 2. So we're going this way, including 2. So when I write the domain for this, on the left is -infinity, and on the right is 2. Just remember that infinity always gets a parenthesis because infinity is not an exact position in space. It's more conceptual. So it's not like it always gets a bracket, positive or negative infinity, because it's not an exact position in space. You can't like stop at -infinity where I can stop at 2, okay? All right, gang, so that's it. That's for domain. So if you have a radical with an even index, make sure that what's under the radical is greater than or equal to 0. Okay, that's it on this video. Hope it helped. Bye-bye.